We're going to continue our look at nucleophilic acyl substitution by enolates by focusing on mixed and directed Claisen condensations. In the previous video, we talked about Claisen condensations, which start when a base grabs off an alpha proton next to an ester, generating some of an enolate. But what happens if we have multiple esters and we want to get those esters to react with each other? Well, if we just mix them together, then the alkoxide can also grab off some of this alpha hydrogen, which is going to lead to the formation of this enolate as well. In addition to both of these enolates, we still have a lot of ester because the equilibrium lies toward the esters. So that means we have an enolate that can add to this carbonyl and one that can add to this carbonyl. And over here, we have an enolate that can add to this carbonyl and to this carbonyl. So for this particular reaction, we get a big mixture. What we will end up with will include our products will include all four of these products. So when the enolate derived from this ester reacts with that ester, we get some of the self-addition product. When this enolate reacts with the other ester, we are going to make some of this product. When the enolate derived from our second ester reacts with that second ester, we make some of this product. And when this enolate reacts with our first ester, we get some of this product. So a mixed Claisen condensation can lead to 4 different products. Now keep in mind, just like with a mixed aldol, a mixed Claisen doesn't necessarily mean you have a mixture. It means you are using 2 different components. But what we need to figure out is whether it's possible to minimize the number of products that we actually get. Think about what we did with the aldol fix. One way to fix it is based on the choice of reactants, and the second way is based on the choice of other reagents. So in terms of the reactants, if we have one component that can't form an enolate reacting with a second component that's more reactive as the electrophile, then we will get primarily one product. Or if we use a very strong base such as LDA rather than using methoxide, then we can convert all of one ester to the enolate and then introduce the second ester. So let's see whether what we had talked about for aldol is that also going to work for Claisen. Here we have a few examples of mixed Claisen condensations. And so we have these 2 esters. This one cannot form an enolate, so only this one can form the enolates. Now, it just happens that when it comes to nucleophilic attack, this carbon is more susceptible to nucleophilic attack than this one is. So our major product will result from nucleophilic acyl substitution on the benzoate ester. So our major product will look like this. And we might get some self-addition as well. Don't forget what we talked about in terms of the position of equilibrium and the fact that this has to get deprotonated to lead to a favorable equilibrium, and then the H3O plus is added to quench that enolate. I'm not going to go through all of those steps each time, but it is still important to keep in mind. If we look at our next example, this ester is more reactive as an electrophile than this ester, but this is the only one that can form an enolate. So we're going to form some of this once again, and then this will primarily react with the other ester, giving us this product. And again, probably trace amount of self-condensation. Here's another type of ester. This is a carbonate ester, and this is also very reactive as an electrophile, but it cannot form an enolate. This one can form an enolate. So this time we are going to make some of this enolate, and then this enolate will react primarily with this carbonate ester. And that is going to lead to a product that looks like this. So if your target is this type of compound and you are able to use reactants that are different enough in reactivity, then you should be able to get one major product of the mixed Claisen condensation. Notice what we're making here. Again, here we have some beta keto ester, another beta keto ester, or a beta aldehyde ester. Here we have a beta diester. So keep in mind, these two could be used as starting materials in the acetoacetic ester synthesis. This one could be used as a starting material in the malonic ester synthesis. So mixed Claisen condensations can be carried out to give only one major product if you are using the correct combination of reactants. But what if the reactants you want to use are not inherently different in reactivity, right? If you can't address these two issues, then is there another way to go? And the answer is yes. Rather than just doing a mixed Claisen, we can do a directed Claisen where we use LDA to form one enolate essentially completely and then have that react with the other ester. So a few slides ago, we showed the reaction between these two esters treated with methoxide, and it led to a mixture of 4 different products. What if we instead use LDA? Let's start with the first ester. And if we treat this with LDA, remember in this case the equilibrium lies very, very far to the right, so that we make essentially all of this enolate. And now there is very little of this ester for it to react with, so we don't have to worry about self-addition. Instead, nothing really happens until we add in the second ester, and this will add here, push these electrons up, back down, kick this out, and we will end up with only one product, not a mixture of 4. If we carried out this reaction in the other direction, so we started with this ester and we treat it with LDA to give this enolate. Because the equilibrium lies so far to the right, we don't have to worry about self-addition, and this enolate will just hang around until the second ester is added. And now this can attack here, push the electrons up, come back down, kick out the methoxy group. And we will end up with a product that looks like this. So a few slides ago, we saw that these two esters could lead to a mixture of 4 products. Well, now we can see that we can obtain any one of those 4 products selectively. If we want the self-addition product, then of course we just use this with methoxide. Or if we want this self-condensation product, we just use this with methoxide. If we want this to be our nucleophile and this to be our electrophile, then we react this first with LDA and then the second ester leading to this product. Or if we want this to be our nucleophile, then we first treat this with LDA before adding in the second ester to give us this product. So this means that we have the ability to control which product is formed by choosing the appropriate reagents and by mixing them together in the correct order.